You think Earth sits at the center of the universe. Wrong. In reality, we live inside a vast cosmic desert, a terrifying void with a diameter of 2 billion light-years. And Earth happens to lie almost exactly at its center. This isn't science fiction. It's a hypothesis proposed by astronomers in 2013. It's called the KBC Void, the largest cosmic emptiness known to humanity. Inside this void, there is almost nothing. The matter density is only 1/5 that of the normal universe. To put it simply, if the normal universe is a bustling metropolis, then we are living in the deepest heart of the Sahara Desert. For 2 billion light-years in every direction, there is near lifeless darkness. This may explain a chilling mystery: why humanity has searched for so long, and still found no trace of extraterrestrial civilizations. Maybe aliens don't exist. Or maybe we are trapped in the universe's most barren wasteland. Like a fish born in the deadest zone of the ocean, it would never know how lively the coral reefs are far away. Even more unsettling, the existence of this void is shaking our most basic understanding of the universe. Scientists have found that the observed rate of cosmic expansion does not match theoretical predictions at all, and the KBC void may be the missing variable. But here's the problem: why should anyone believe something this outrageous? In 2013, 3 astronomers did something simple and insane. They counted galaxies. They analyzed the spectral data of 35,000 galaxies. One by one, they discovered that within a radius of 1 billion light-years centered on Earth, the galaxy density is significantly lower than expected. But once you cross that boundary, the number of galaxies suddenly jumps to 1.5 times the previous level. What does that mean? It means we are surrounded by a gigantic bubble, and the inside of that bubble is nearly empty. The 3 scientists named this bubble, using the initials of their last names, the KBC Void. From that moment on, a crack opened in humanity's picture of the universe. But the academic community wasn't convinced. Critics asked, what if distant galaxies are hidden by cosmic dust? What if you simply miss them? Isn't this like counting stars in the night sky? The farther they are, the harder they are to see. Skepticism poured in from all sides. For a time, the very existence of the KBC Void was marked with a giant question mark. That changed in May 2025. A paper published in Monthly Notices of the Royal Astronomical Society completely shifted the situation. This time, scientists used a different ruler. They stopped counting galaxies and switched to a far more precise method: baryon acoustic oscillations, or BAO. What are baryon acoustic oscillations? They sound mysterious, but the idea is actually simple. Shortly after the universe was born 13.8 billion years ago, it was a boiling plasma soup. Matter and photons were tightly coupled. In regions of higher density, gravity pulled matter inward, while high-energy photons pushed it outward. This push and pull created expanding pressure waves, like ripples spreading across a pond when you throw in a stone. These ripples expanded until the universe cooled to about 3000 Kelvin. Electrons and protons finally combined into atoms. Photons were released, and the ripples froze forever into the structure of the universe. The diameter of these fossil ripples is about 1 billion light-years. They act like a natural cosmic measuring stick. Find the ripples, and you can measure cosmic distances precisely. But there's a catch. This ruler isn't directly visible. It's inferred through galaxy redshifts and viewing angles. And redshift data is strongly affected by voids. Why? Because if we truly live near the center of a void, 2 strange effects occur. First, the matter density outside the void is higher, so gravity there is stronger. Galaxies inside the void are gravitationally pulled outward. This extra motion adds to the expansion of the universe, making galaxies appear to recede faster than they really are. Second, according to Einstein's general relativity, light loses energy as it escapes a gravitational field. The gravitational field near the edge of the void is stronger, so light emitted there experiences additional redshift. Together, these 2 effects cause us to seriously overestimate the recession speed of nearby galaxies. And this perfectly explains a crisis that has plagued astronomy for nearly a decade: the Hubble tension. The Hubble constant describes the expansion rate of the universe. There are 2 main ways to measure it. The first use is supernovae. By observing nearby Type Ia supernovae and analyzing their redshifts, scientists obtain a Hubble constant of about 73. That means for every 3.26 million light-years, galaxies recede 73 kilometers per second faster. The second method uses the cosmic microwave background, the afterglow of the Big Bang. Analyzing that data yields a value of about 67. 73 versus 67, a difference of nearly 9%. That may sound small, but it far exceeds experimental error. What does that mean? Either our measurements are wrong, or our understanding of the universe is fundamentally flawed. Scientists have argued about this for over a decade. Countless hypotheses were proposed. Some blamed faulty instruments, until the James Webb Space Telescope ruled that out. Some suggested the universe is rotating, with no evidence. Others proposed rewriting physics itself, introducing exotic ideas like dynamic dark energy. But the KBC Void offers a far more elegant explanation. If we really live inside a void, then supernova measurements mostly sample nearby galaxies. Galaxies that are also inside the void. Their redshifts are overestimated, so the calculated Hubble constant is too high. The cosmic microwave background, by contrast, represents the average of the entire universe, unaffected by local voids. That's why its value of 67 reflects the universe's true expansion rate. In 2025, researchers formally applied this idea, analyzing 20 years of BAO data. They found that high redshift, distant data, matches the standard model perfectly, but low redshift, nearby data, below 0.2, deviates sharply from predictions, exactly as the KBC Void model predicts. Even more astonishing, at the 2025 National Astronomy Conference, researchers presented a striking statistic. The void model is 100 million times more likely than the no-void model. This all but declares that we truly live inside a gigantic cosmic void. But the story doesn't end there. The KBC Void also sheds light on another haunting mystery, the Fermi paradox. In 1950, physicist Enrico Fermi casually asked during lunch, "Where is everybody?" By everybody, he meant aliens. The universe is enormous. Stars are everywhere. By probability alone, intelligent civilizations should be common. So why haven't we found a single one? The KBC Void offers three chilling answers. First, resource scarcity. There are fewer galaxies inside the void, fewer stars, fewer planets. The odds of life emerging are naturally lower. Our existence may be a rare accident among rare accidents. Second, distance isolation. Even if countless civilizations exist outside the void, they are separated from us by 2 billion light-years of emptiness. Even traveling at light speed, it would take 2 billion years to cross. Contact is impossible. Even signals can't reach us. Third, deliberate avoidance. If you were an advanced civilization, where would you explore? Dense, resource-rich galaxy clusters. Why waste effort probing a cosmic desert? From an alien perspective, we may simply be a place not worth investigating. Even more unsettling, some scientists propose this isn't a coincidence at all. This idea is known as the anthropic principle. In short, only an environment like this could give rise to a civilization like ours. In dense regions, galaxy collisions are frequent, supernovae are common, and lethal radiation is intense. For fragile life, that's hell. Only in a relatively quiet void could life have enough time to evolve, to think, to gaze at the stars. In other words, cosmic voids may be the cradle of advanced civilizations, while bustling star clusters may be their graveyards. This is philosophical speculation, not scientific conclusion. But regardless, the discovery of the KBC Void has fundamentally shaken humanity's worldview. We once believed the universe was uniform on large scales, the cosmological principle, one of the pillars of modern cosmology. But the KBC Void says otherwise. The universe is not uniform, at least within our 2 billion light-year neighborhood. Matter is distributed unevenly. Even more troubling, according to current cosmological models, a void this large should not exist. Theory predicts a maximum void size of about 100 million light-years. The KBC Void is 20 times larger. What does that imply? Either our theories need revision, or the universe is far stranger than we imagined. In September 2025, Scientific American published an article that stirred the waters even more. A research team used computer simulations to reconstruct the structure of our local universe. They successfully reproduced most known superclusters, but the KBC Void was nowhere to be found in the simulations. What does that mean? It means our understanding of the KBC Void is still incomplete. It may exist, but we don't yet fully grasp its boundaries, depth, or origin. Some suggest it formed from the merger of many smaller voids, like bubbles fusing into a larger one. Others argue accelerated dark energy expansion pulled matter away from the center. And some propose an even wilder idea. Could this be a mining scar left behind by a super-advanced civilization harvesting galactic energy? It sounds like science fiction, but on cosmic scales, who can say for sure? Whether the KBC Void is ultimately confirmed or overturned, it has already delivered a crucial lesson. Our location in the universe may be far more special than we ever imagined. The KBC Void may be the newest annotation on humanity's cosmic map. We thought we lived in a city. In reality, we dwell deep in the desert. We thought the universe was bustling. In truth, 2 billion light-years around us are silent. We thought aliens would come visit. In reality, no one may even know we're here. That sounds lonely, but seen another way, perhaps this loneliness protected us, allowing this small blue planet to survive the 13.8 billion-year evolution of the universe.